Tonight's notes are on section 3.1. Make sure you have your calculators handy. You'll be able to do almost all of these questions in the calculator, with the exception of just this first one. Now, I want to make a note that some calculators will reduce radicals for you, and the TI 83s and 84s can do it if you go online and put a program onto the, like if you download a program onto them. So if you're like tech savvy and you want to give that a try, go for it. But otherwise, this you would have to do by hand. So when we are reducing any radical, the question is there a perfect square that is a factor of this number? So is there a perfect square that is a factor of 90? And the answer is yes, of course there is, a 9. And now, since this is a negative 90, I'm actually going to make that a negative 9. So if you have a negative, always put that negative with your perfect square factor. And then what number do I multiply 9 by to get to 90? So that would be a 10. So this is always your perfect square factor, and this is always what number you would need to get a product of the number you're reducing. Okay. And why do we choose perfect squares? Well, because now we can reduce this. The square root of 9 is 3, but the negative under the radical means that we need an I. So the square root of negative 1 is I, which means the square root of negative 9 is 3I. Okay, so anytime there's a negative under a radical, we get an I, and I is the square root of negative 1. So these are complex numbers. They are numbers that exist outside of real numbers. And this is what happens when we have negatives under radicals. So when we are adding and subtracting terms, complex numbers, we just add and subtract real parts and then add or subtract imaginary parts. The process is the same as when you're dealing with variables. So here I would add the negative 11 and negative 20 and get negative 31. And then I would add the negative 8 and the 21 and get 13i. So a negative 8i and a 21i would be 13i. Okay, so same thing right here. We're going to subtract. Negative 19 minus 8 would be negative 27. And then 16i minus a negative 8i would be the same as 16i plus 8i, which would be 24i. Okay. And then when we're multiplying, we're also going to multiply the same way that we would if that was just any other variable in the beginning. So 2 times 10 is 20. 2 times a minus 3i is a minus 6i. Negative 2i times 10 is a negative 20i. And negative 2i times a negative 3i is a positive 6i squared. Now, before I told you that I is the square root of negative 1. So what that means is that I squared is negative 1. So the way that these differ from any other problem with any other variable is that anytime we have an I squared, we need to change that to negative 1. So I'm going to take this I squared and make it negative 1. And so then what I have here is 20 minus 6i minus 20i. And instead of plus 6i squared, minus 6, no I anymore. And now I combine like terms. So 20 minus 6 is 14. And a negative 6i minus 20i would be minus 26i. So i's cannot be in the denominator of a fraction. So if you have an I in the denominator of a fraction and you have a monomial, so just one single term in that denominator, then you're just going to multiply top and bottom by I. And so on the top here, I wind up with 4i plus 3i squared. And on the bottom here, I wind up with 3i squared. And now we just said that I squared is -1, so then this would become 4i plus 3 times -1 over 3 times -1. So now I have 4i minus 3 over minus 3. Okay, so when we're writing complex numbers, we always write the real part first and then the complex part second. So I need to rewrite this so that it is -3 plus 4i. So your I should always be in the back like this. And then for proper a plus bi, I have to split this. So basically you just give each piece in the numerator the denominator separately like that. And then reduce each piece. So a -3 over -3 is 1. And 4 over -3 would be a -4/3. So my final answer here is 1 minus 4/3 I. So if you have a monomial, you just multiply top and bottom by I. But if you have a binomial, then you multiply top and bottom by the complex conjugate of that binomial. The complex conjugate of this binomial is the same thing that we have in the denominator, only with a different sign in the middle. So we keep the sign in the front if there is one, and then we only change the sign in the middle. And now I could multiply the numerators and then multiply the denominators and then reduce and blah, 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 but I don't feel like doing that because outside of that first problem, every single one of these can be done in the calculator. So if we grab our calculators, if you look right here above the decimal point, you'll see there's your I. There you go. See it right there? I is right above your decimal point. So we press second and then decimal point to get to I. So if you use that I and you put these in exactly like you see them on the page, what did I do? It's 20 plus 21i. If you put them in exactly like you see them on the page, I didn't put that one in exactly, then you'll see that you'll get the answers. So -19 plus 16i minus 8 minus 8i. Two minus 2i, 2 minus 3i. There it is. And now for the questions where you're dividing, you don't need to do this multiplication. You just have to put the problem in as it's given to you. Just remember that the numerator and the denominator each need their own parentheses. So we would do parentheses for plus 3i divided by parentheses 3i. And I know that I've showed you this trick before, but I just want to let you know that it does work with i's. So if you press math, enter, your calculator will turn a complex number into a fraction. So there's your final a plus bi form. Okay. And so then for this one, we would do 4 plus 137i divided by negative 11 plus 10i. Again, numerator and denominator in their own separate parentheses. So the final answer here will be 6 minus 7i. And now in his lesson, Andy went into a really
I have a question.
Yeah.
I'm sorry. Is it supposed to be negative 11 minus 10i or negative 11 plus 10i?
Nope, write it in exactly as it's written on the page.
Exactly as a denominator, nothing changes.
Nope. So you would change it to negative 11 minus 10i if you were multiplying by hand. This is essentially what the calculator is doing.
Oh, duh, you're just putting in. Okay, I'm sorry.
Yeah,
okay.
No problem. So Angie goes into a really great explanation on how these powers of I work and what the pattern is, and I think that he does a great job explaining it. And I also think that I don't want to basically just sit here and repeat word for word what he said. So what I do want to do is show you that while his explanation is great and true, and I think that that pattern is very interesting, you also could just put these in the calculator. Okay. So, I mean, that's 3.1.
Well, thank you for that.
Probably the easiest section of the semester. Yeah. 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 I mean, his explanation is good, but it's a weird concept, and I get that. So don't feel guilty about just putting this in the calculator, okay?